This is a presentation to quickly go over some of the major changes between the ASCE 710 and the ASCE 716 that pertain to most projects that JEI Structural Engineering specialize with. These changes will be reflected in the 2018 International Building Code. This disclaimer is basically explaining that this is a brief and cursory presentation on the changes between the ASCE 710 and the ASCE 716 that pertain to most JEI structural engineering projects. For more depth, it's encouraged to go through the code itself. With that said, let's get underway. This is the table of contents for this presentation, and these are the four main chapters with changes from the previous code that I will be going over. Chapters that are not listed here are either not relevant to most JEI projects or have not changed from the ASCE 710. To start, let's have a look at Chapter 2, Combinations of Loads. Chapter 2, Combinations of Loads. The only item that's changed that's worth noting is that the seismic forces have been split into their horizontal and vertical components within the load combinations. This doesn't affect the calculations themselves, but it is related to the formatting and structure of calculations and is worth noting. Of the four chapters that I'll be discussing, this has the least amount of changes by far. Now let's move on to the next chapter, Chapter 7, Snow Loads. In Chapter 7, several states that were previously case study regions have had their ground snow load values listed per city and county. JEI recommends contacting the authority having jurisdiction for a project before designing for a certain ground snow load, but this does give a good basis for preliminary designs and understanding just how widely ground snow load values can vary just across one state. The ground snow load map contours and snow loads themselves have not changed from the ASCE 710. Another thing that has been added in the 716 is that the drift height has been modified by a factor to adjust for risk category. This factor is a minimum of 0.9 for risk category 1 buildings and a maximum of 1.1 for risk category 4 buildings. For the next two chapters, we will go over wind loads. The third chapter for this presentation is to cover Chapter 26, Wind Loads. Overall, the structure of this chapter has changed so that it is much easier to read and is generally more cohesive. Also, the velocity pressure equation now includes one new variable, K sub E, which is the ground elevation factor. This new factor allows you to reduce the pressure based on your altitude above sea level, or can be conservatively assumed to be 1.0. Something also worth noting is that the height coefficient, K sub Z, has increased for main wind force resisting systems, exposure B and below 30 feet. This does not affect components and cladding pressures. Perhaps one of the largest changes in Chapter 26 from the ASCE 710 to the 716 are the Windspeed maps, which are shown in the next slide. This is a comparison of the Windspeed maps of the ASCE 710 on the left and the ASCE 716 on the right. These wind speeds are both for risk category 2 buildings. The wind pressures within the continental US have overall been reduced. As you can see, per the 710, the wind speed for most risk category 2 buildings within the US is 115 miles an hour. However, in ASCE 716, it's a maximum of 114 miles an hour and then gradually drops off in every direction, except for the coastal pressures on the east, which are shaded in yellow. And those coastal pressures have not changed from the ASCE 710. It's also worth noting that Hawaii and Alaska received very detailed wind speed maps in the 716, which are not shown. But next, let's go over the last chapter in this presentation, which is Chapter 30, Components and Cladding. Chapter 30 is arguably the most influential chapter for most JEI projects, and there have been a few changes from the previous code. The first is that external pressure coefficients for roofs have changed, which results in a change of wind pressure on the different zones of a building's roof. I won't be going over the exact and specific numbers for this presentation, but overall, most of the external pressure coefficients for roofs have increased. Also, the wind zone locations have changed more for some roof types, which I'll go over in the next slide. But perhaps the largest thing worth noting is that the external pressure coefficients for Zone 5, which are the walls located at a building's corner, and Zone 4, which are walls that are not located at corners, have not changed. This is significant because since the wind speeds have generally decreased for most of the United States, and if you utilize the new elevation factor to reduce the pressures even further, there will be a net reduction of wind pressures on walls for components and cladding in the 2018 International Building Code. In the next slide, there's a comparison of the different roof zone dimensions between the ASCE 710 and the 716. Here is a comparison of how the roof corner zones have changed from the 710 to the 716. For our projects, this mostly affects the pressures on skylights and rooftop appurtenances. For a gable roof, the interior roof zone, Zone 1, has been split into Zones 1 and 1 prime. And the roof corner Zone 3 shape has changed considerably, as you can see in the roof zone dimensions below. Overall, this may affect fastening patterns for roofs within the upcoming International Building Code. This is the end of this presentation, and I hope that this has been of some help in explaining the changes from the ASCE 710 and the 716, which will be adopted in the upcoming 2018 International Building Code. Thanks for watching.